Now let's review linear inequalities. For linear inequalities, we're talking about a set of numbers. So it's not just x equals 1 or x equals -1. We talk about x greater or equal to -1, which is many numbers. So greater than -1 could be 1, could be 0, 2, 3, 4, 5, and so on. So first, make sure you know how to graph an inequality. So right here, we have x greater or equal to -1. So first, let's just locate -1. So I'm sorry about the number line right here. It's kind of messy. So let's say this is -1. For -1, the reason I use a closed circle is because we have the equal sign. So greater means to the right. Now, for number 11, we want to do the opposite. They give you the graph, and now you have to write the inequality. So as you can see, we start at -2 and go to the left. So it's going to be x less than -2. And then notice that it's an open circle, so I keep it strictly less than -2. Moving on to number 12, we have to graph the compound inequality on the number line. So what we have to take a look at n right here. That means it's the intersection, right? So we have all the number less than greater than -3 and less than or equal to 5. So we have 5 included and -3, open circle, and everything in between. Now for number 13, you can see that everything in between 3, including 3 and 9. So the compound inequality would be 3, less than or equal to x less than 9. Okay, number 14. We have to graph the set of x such that x is in between -7 and -5. And I'm just going to write the number here. So -7 and -5. For -7 is open, for -5 is closed, because we have the equal sign. So we have to include -5. All right, those are very easy problems. I want to talk about the union and the intersection. These are the more important problems. So you see right here, every time they ask you to write C intersects D, that means everything include in C and D. For the union is OR. So intersection is N. Union is OR. So for this problem, I always try to graph first. So, and I use two different numbers, two different colors to graph. So for C, I'm just gonna locate 3 and 6 first. So 3 we included, 6 we keep it open. Okay. So C. What do we have for C? C is the set of y such that y less than or equal to 3. So it's going to be to the left. I'm going to use different color. And then for D, is less than 6 as well. So it's to the left as well. Okay, make sure you don't stop at 3 because y less than 6 also means y less than 3. So we want to keep both colors that way. Now, for the intersections, you want to locate where we have both colors. In this case, it's going to be from negative infinity, and we stop at 3, included. For union, where you see colors, that's your solution set, start and end. So it starts from negative infinity and it ends at 6. Don't include that one because of the strictly less than 6. All right. Now, moving on to solving inequalities. It's really simple. We do exactly like linear equation. So first, I want to add 4. Add 4. And then I have negative 8 less than or equal to 4x. Divide by 4. Divide by 4. So what I have is negative 2 less than or equal to x. To be honest with you, when it's come to inequality, I want to write the variable on the left-hand side. It looks better that way. So x less than or equal to negative 2. Okay. So exactly the same. Like I said, usually I keep the variable on the left-hand side. So I'm going to subtract 3w. Subtract 3w. So I get negative 6w minus 14 less than 16. Add 14. Add 14. So we have negative 6w less than 30. All right, I'm glad I have this problem because this is the only thing different from linear equation. When you divide by a negative number, make sure you flip the sign. So that's important. You flip the sign. Okay, so keep that in mind. When you multiply or divide by a negative number, you flip the sign. All right, moving on to number 18. Number 18 is quite important. Okay, first I want you to notice that they're asking you for n, which is the intersection. Now solving is easy. So we have 4x plus 6 less than or equal to, greater than or equal to negative 6. So I have minus 6, minus 6. Negative 3. For the other one, we have 2x minus 2 less than 4. All right, so I'm not going to use that number line. So let me see because it's a little bit confusing with all the numbers. So here, I'm going to do this. So we have negative 3 and positive 3. All right. So like I said, I'm going to use two different colors. For negative 3, we have greater. Okay. For positive 3, we have less than. So it's this way. All right. Now, we are looking for n. So earlier I mentioned that the intersection, you have to see where the colors meet, right? So it's only from negative 3 to 3. That's for the intersection. Now, if I ask you, if I use the same problems, I use the same inequality, and I change it a little bit, instead of asking for n, I'm going to ask for or. That's going to be completely different. Now, where you see colors, that's going to be your solution set. So I see colors starting from negative infinity all the way to positive infinity. This is for OR. And negative 3 and 3, that's for N. Okay. So number 19. You see right here? They're asking for OR. Okay, so let's do it. We have -6 for that one, and then we have for 4v plus 1 greater or equal to -7 minus 1, I get -8, v greater or equal to -2. All right, let's graph. I have -2 here and I have 5 here. For -2 is included. For 5 is open. Now, let's take a look at greater than 5, which is this way. Greater or equal to -2, also this way. This is a good problem. So for OR, where do we start seeing color as -2? So it's going to be -2 to infinity. Now I'm going to also put, so this is for OR. As I mentioned earlier, if I ask you for N, the answer is going to change. Now you see this is where the two colors meet, right? So we cannot start from here because you only see yellow here. This is where you see both colors. So for N, the answer is going to be 5 to positive infinity.